Let's look at this example of a measurement question. We have the triangle here, ABC. See that AB is 56 meters long. BC is also 56 meters long. We have 75 degrees in this corner. Angle ACB is 75. Remember, when you say ACB, is ACB like that. And it's the angle at the corner here that you're talking about, that you want to find. Alright. You could, first of all, don't assume it's a right angle triangle. You weren't told, right? The sine, cosine, and tangent ratios won't work. Where it says sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. Those won't work here because you're not told that it's a right angle triangle. By the way, it is an isosceles triangle, two sides the same length. So these two angles would be the same. They say you must calculate the length of AC and the two angles BAC and so on. What you can say here, since AB and AC are the same length, then angle BAC, right, this angle here is the same size as ACB, this angle here. So BAC is 75 degrees. Alright, so the angle BAC is 75 degrees. You can see that, isosceles. Alright, we found that. ABC, angle ABC, this angle here. Alright, we can find the angles even before we find AC. Now, let's see now. You know that 75, this angle plus 75 plus angle ABC all add up to 180. 75 and 75 is 150. Right? 150 plus ABC is equal to 180. So the angle ABC would be 180 minus 150, which is 30 degrees. So this is a 30 degree angle here. Right. So what is this length here? AC. What we do here is to say, we could use a sine rule to calculate it. Let me see what the sine rule say. I have the sine and cosine rule somewhere here. Right, the sine and cosine rule can be used on any triangle at all. Here we have the sine rule in the C-Sec mathematics formula sheet. It says A, this angle A, over the sine, no, not the angle, the side A, the side over the sine of the angle opposite to it, over sine A is the length of side B, the side over the sine of the angle opposite to it, equal to C, the side over the sine of the angle opposite to C. Okay, that's what the sine rule says. Then we have the cosine rule. Cosine rule says A squared, this angle squared, equal B squared, the next angle squared, plus C squared, which is the next angle squared, minus 2BC cos of the angle opposite to A. So we have the sine and cosine rule in the C-Sec Maths formula sheet. Now let's try use the sine rule. If this is angle B, big B, this would be side small b. If this is angle big C, this is side small c. This is angle big A, this is side small a. So what we say is A over sine A equal B over sine B equals C over sine C. So A, 56 over the sine of 75 equal B, whatever it is, over the sine of 30. We don't need to go any further. You know, we can calculate this part. 56 divided by sine 75, what is it? Alright, let's get our calculator. 56 over sine 75. 56 divided by the sine of 75, it's in degrees, right? Equal, alright, so it's 57.975. 57.975. So 57.975 equals B over sine 30. I remember that sine 30 is a half, 0.5. Running out of space, you know. Let's use this space up here. We'll continue. So therefore, multiply both sides by 0.5. B is equal to 0.5 times 57.975. So it's the same as this, over 2 divided by 2 equal 28.99. Call it 29 then. So we have B is equal to 29 centimeters. Alright, so it's 29 cm. B equal 29 cm, which is AC. 29 cm. We found ABC as 30. Alright, finally we want the area of a triangle. Let's see what's happening here now. Let's erase these. The area of a triangle. Now, let's use the formula. The area equal half AB sine C. No, half small a small b sine C, I should say. It's like you have this triangle, and this is C, small c. This is angle A. This is small a. This is angle B, big B, small b here. Half the area is half two sides multiplied by the sine of the angle between them. So let's try it on this. Let's try it with the 30 here. The area is half 56 by 56 by sine 30. So half by 56 by 56 by sine 30. So I said that sine 30 was equal, but I didn't clear the calculator. I said before sine 30 equals a half. So it's half times half. So this is sine 30, which is half, times 0.5, which will give you a quarter, 0.25, times 56 by 56. So times 56 times 56 equal 784. So the area of a triangle is 784 centimeters squared. Write that down, 784. Alright, good. Suppose we try another way to calculate the area of a triangle. If we consider this triangle here, right? You can see it's a right angle triangle. It's turned upside down though. If this is 29, half of 29 is what? 14 and a half. So from here to the middle is 14.5. So but we don't have to do that. Just use the entire triangle, right? We don't have to do that. Let me get rid of these markings that are made. We don't need to go through all of that. Imagine this triangle is turned upside down, right? Let me see now. Oh, we're going to have to find this vertical height. So we're going to use trigonometry. We said it was 784. If you should try it the other way with it, well, when I say we're going to use trigonometry, I'm talking about sine and so on. Oh, might as well we just consider taking the triangle out instead of trying to work with it mixed up with everything else. Let's just take one side of the triangle out. I have the right angle here. We have the 75 degrees here. Half of 29 is 14.5, and this is 56. What is this height? We're going to use Pythagoras Theorem, right? So what we would say, if we want to find this height here, Pythagoras Theorem says the hypotenuse squared equal, call this h, the height here squared plus the other side square, 14.5 squared. So if we transpose, we would get the height squared is equal to 56 squared minus 14.5 squared. What is 56 squared minus 14.5 squared? 56, do I have square here? Should have square. To the power of 2. 3136. So what we have here is 3136 minus 14.5 squared. So we have 14.5 squared. I don't have a direct square here. What I have is to the power of 2, or I could just multiply the numbers. 210.25. 210.25. That's 8 squared. Alright, so let's work over here. 8 squared equal, subtract these, 3136 minus 210.25. So we have 3136 minus 210.25 equal, you have 2925.75, 2925.75. So the h is the square root of 2925.75. So let's find the square root of that. Square root of that equal 54. Let's call it 54 flat. Alright, 54. This is 54. So now what we can do, since we know that this is 54, alright, let's try the area of this one. The area is half the base, 14.5, times the vertical height, which is 54. So 54 by the base, 14.5, 54 by 14.5 by half. This by 14.5 by 0.5 gives us 392.15. So the area of this triangle is 392.15. Let's erase some of these things that we had here. So we have 392.15. But then, if we calculate the area of both triangles now, we have to multiply this by 2. So this times 2 equal 784. Well, it's 784. So we have the area is equal to 392.15 equals 784. Right, so you see we get back the 784. right? So we tried the half AB sine C gets 784, and we cut this into two right angle triangles, use Pythagoras to find the vertical height, find half base time vertical height for half of it, then add the two of them and we get back our 784. So those are two ways you could do it. Alright, I will see you in the next video.